prisms, and they're named for the shape of their base. And this, because its base, which we'll talk about later, is a triangle, this is a triangular prism. This one, because its base is a rectangle, is a rectangular prism. And this one, it could technically be a square prism or even a rectangular prism, but we have a special name that we call that. That is a cube. And what makes a cube a cube? Wade?
All sides are squares.
All sides are squares. And if you're going to draw these shapes, really the simplest thing to do is this. What makes the prisms is that their bases are identical. So let's say you were trying to draw a triangular prism. Really, all you need to do is you start with a triangle. If you can draw an identical triangle, kind of up and over from it, and then connect the corresponding sides, and if the board is working, connect the corresponding sides, you'll get a shape that looks pretty much like a triangular prism. It's helpful though if you sometimes the faces that you don't see, if you make them dashed, it is it is you can put some dash lines back there so that it makes you can tell, and you can dash it anyway. This would be kind of the face of it. This would be another side, and a third side. Bad. Same thing, cubes, that's pretty simple simply because it's a square, and then you just draw a square, what looks like would be a square thing, as much as you can. Rectangular prisms, cereal boxes, shoe boxes, same thing. You start with a rectangle, and you can draw an identical as much as possible rectangle, and then connect the corresponding corners. You get yourself a mighty fine looking rectangular prism there. This one should be dashed too. It'll do nothing but help you if you can sketch these things out in your mathematical careers. Because you will have to label those and do all that sort of thing there. This one right here, forging ahead. If something comes to a point, we call it a, the Egyptians loved them.
Pyramid.
Yeah, it's a pyramid. And it is named, pyramids are named based on what base makes their bottom. Okay, this is a rectangular. I guess it's just a pyramid. They don't give you, I guess we're just going with pyramid. Don't make it pyramid. Comes to a point. Comes to a point. And those are pretty fun and simple to draw as well. You just have to start with whatever base you want. Let's say I want a rectangular pyramid. I'm going to start with my rectangle, kind of make it look like it's laying flat on the ground. Then you just take a point, put a point above it, and connect all the vertices, all the points there with that point straight down. And you get a handy dandy pyramid. And you could do that with kind of any shape. If you wanted to make an octagonal one, hardest part is drawing this little octagon thing here. You can draw an octagon. I think you would probably draw this. Put your dot up there. That wasn't really squished, was it? You try that again. See if I can draw it a little more squished. Make it look a little flatter. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And put your point up there, and then you just connect all the wall. Looks kind of like a pyramid, doesn't it? Something like that. This guy right here is a. Yep, these are cylinders. Also affectionately called the can. We've got stuff in there. And cylinders are really drawn kind of the same way those other things. Just start yourself with an oval, draw 2 straight lines down from it, and another oval, and then you can put a dashed line up there if you like. You can do the thing there. A cylinder that's actually a pyramid is called a cone. And that's just like your little cylinder, except put a dot in there. Draw your little cylinder thing, and there's your cone in the midst of your cylinder. And the last one, everybody's favorite, is a
Sphere.
sphere. Yeah, you gotta use the math word for it, or a ball. And the best way to draw a sphere, start with your circle, because that doesn't look too three-dimensional if you just draw like an equator around it as a dashed line. Everybody for some reason thinks that that makes it look round. Which I guess it kind of does in some strange way, shape, or form. You got that? Perfect. Now make sure you know, and I think we've done this many times before, when you talk about solids, we have things that are called faces, edges, and vertices. What are the difference between those 3 things? What is a face? What is a face of a solid? Abram?
The sides that are filled in.
Yeah, it's basically the side. You know, faces of this right there's one, here's one, here's one. How many faces does a rectangular prism have? How many faces? Brant?
6.
Yeah, it has 6 faces. How many faces do you have? 1, hopefully. How about edges? What is our edge on this thing? Well, how would you describe an edge? Wade?
Where the faces meet.
Yep, where faces meet. As opposed to Facebook. Face edges would be these parts for these little, I don't want to say corners, but they're not. I mean, they are, but they aren't corners. How many edges does this rectangular prism have? How many edges, if you were counting them up? Cartwright?
24.
Not quite, I don't think. Let's see if we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges. Not sure how you got 24. Were you doubling them? 12 edges. And then vertices are? Vertices are? Lib? Yep. Amelia?
Corners.
Yeah, corners. Corners. And these would be your vertices. A single vertice is called a vertex. How many vertices does my rectangular prism have, Jacob Lick? 8 of them. 8 vertices. 8 vertices. It's gotta be one. Gotta be one. Perfect, and then somewhere, maybe another blank piece of paper here. Actually, do another blank piece of paper and write down the word surface area. Surface area. Since we're talking about a solid, let's look at a cube. Here is a cube. Let's say this cube is 5 inches by 5 inches by 5 inches. Does anybody know what surface area is? We've done area, right? We've done areas of squares, rectangles, and
Yeah.
stuff, yeah? What would surface area be? Well, basically, surface area, put simply, is the area of all sides added together. Say you bought your mother a baseball for Christmas, and you put it in a box because you wanted her to be surprised when she opened it up, which I'm sure most of your mothers would be. You would need the surface area to know how much wrapping paper it would take to cover that box. That's what you're finding out. How much does it take to cover all the sides? So how would you do that? Well, the nice thing is with a cube, what do we know about a cube?
All sides are
Yeah. All the sides of this shape are going to be this 5 inches by 5 inches. So the area of just one side is 5 times 5 is
25.
25 inches squared. How many of those sides does a cube have? 1, 2, 3, 4, 5, 6. So you'd have to take 25 6 times. We have to add these together. Can somebody do 25 times 6? Add them all together. 6 times 25 is 450 times 3. 150 square inches of wrapping paper it would take to get Mom's ball wrapped. It's a baseball look like. Has it got a double seam? Just one. No, just one. Wait, what did they do? Hold on.
They have double seam.
But it goes kind of like this, doesn't it?
It's like, it was like around. Yeah, it's like a weird paper. I don't believe it's all. I do.
150 inches squared. That is surface area. What if it wasn't a cube though? What if it was a cereal box looking shape that looked like this? What would be the surface area of this box? Say it's 10 inches by 3 inches by 12 inches. Well, to do that, we just have enough time. To do this, you might want to write down the different names of the sides. There are 6 sides. What would you call them? Well, we've got this side right here. What would you call this right here? How about the front of the box? Yes, that's a pretty good idea. Now, if you notice something, what do you know about a cereal box? If you look at the front and the back side of it, what are they? They're the same. So the back would be identical to it. They would be the same. What is the area of the front of this cereal box? What's the dimensions? 10 by,
12.
everybody do 10 by 12 in their head? 20. So you've got 2 of those. And your mom would be really happy that you're wrapping up a cereal box for the present.
Cereal.
What would we call this side over here? Yes, the right side. And guess what? If there's a right side, there's a,
Left side.
not that you can read that. What would be the area of the right and the left sides?
36.
Yep, 3 times 12. And then what 2 sides do we have left? Exactly, the top and the bottom. What's the area of the top and the bottom? Yep, 10 times 3, which is 30. So how much wrapping paper are we going to need to wrap up the Wheaties box that has your picture on it? What, 12? What's that, 10, 17? Looks like 372 what? Inches squared, because it's area, square inches. It would take some wrapping paper to wrap up that cereal box.